We touched briefly on two seminal people in computation, Alan Turing and John von Neumann. Let's go back and just touch on one thing that each of them did to see how critical their impact was. Turing, when he developed his Turing machine, posed a question. If I program the machine, how do I know the program will stop? And you'd say, well, isn't it obvious? You just look at the program. But what if all you have is the machine that has the program loaded into it and it's running? How do you know it's going to stop? And this was tied directly into David Hilbert's goal of axiomatizing, of developing axioms for all areas of mathematics. And in particular, you'd have a set of axioms, and this would lead to, from the axioms to a set of theorems that would completely contain that subject. What Turing and before that, Kurt Gödel did was they showed that there are instances where things can be stated, such as this program will stop or this program will not stop, and yet they're beyond the scope of any axiomatic theory. They lie outside it, and yet they're perfectly reasonable questions to go ask, which showed that what Hilbert was proposing was doomed at the start, which was not obvious. The second one, John von Neumann, dealt with the issue of programming the computer. So I have a computer, there it is. How in the world do I program it? Well, I put a program into it. But how do I put the program into it? Because I need a program to get the program to work. So von Neumann developed the notion of what's called bootstrapping today, that we find in all of our digital devices. And a small program called a bootstrap loader loads itself, and that in turn, now that it's running, pulls in all these other programs, and everything starts to get loaded and works. A non-trivial achievement that we use every day.